Hello all. In this video, we are going to continue with Bangalore house price prediction hands-on project. In this last week, I found there was some mistake. Later, I found some mistakes, and today I'm going to discuss those mistakes and how can we fix those mistakes. So first, let me show. Let me just open the R. Okay. So let me quickly go through the data set that we were working on. So here is we were reading in this line, we were reading the Bangalore house price data set. So here is the data set. And so area type, availability, location, you have already seen this data set. So first we handled the BHK. So there was a quote unquote different ways of writing BHK. So we created a column with variable name BHK. Initially it was a character variable, then we made it to numeric, and then we handled the total square feet. We compared the total square feet, and then finally total square feet was converted into numeric. So here is the total square feet and BHK, which were converted into from character to numeric. Now then we took the locations, and there were about quite a few 1300 locations that we found, and out of that quite a few locations we have only one instances. So what we did, first thing, that we ran this and we say that okay, if dummy variable is less than 20, then it is others. But what I made a mistake, that I made a double equal to sign. In the double equal to sign, actually it will not do anything, okay, and it will just check whether it is true or false, and it will go ahead. So basically we should have put others here. And first, if you don't run it, if you run this, you will not get any others. Effectively here, none of them are others. There is no others locations. So this so basically what I was doing, that there are locations which has instances less than 20. If it is less than 20, you put it into the others location, and rest of them will be as usual. So but it was a sort of an ad hoc correction. So and then when we did run this, what we found, that so it was not doing anything. We found that location was, the first model had a 42% accuracy, and the second model had about 62% accuracy. Okay, yeah, about 62% in sample accuracy. And then we did some test of the values, and for Rajajinagar and all, and then we did a overall try to do the prediction. The prediction was failing. One reason the prediction was failing, that there were locations which came in the test data set, but those locations were not there in the training data set. As a result, the model was not trained for those locations. Okay, and that is why it was throwing the error. And one reason was it was not correctly coded here. So if I do it now it will be doing correctly coding. Now if you do that and run this, okay, and now you see 42%, and if you add location, after adding location you are getting only 45%. So that means if I really correctly do the others, then it will reduce my accuracy of the model. And this adding other locations, just because I don't have enough data, I will club them into others, is not a very good idea. correct? Because it is actually reducing the model accuracy to, even in the in sample accuracy it is reducing. So I don't think we should go ahead with this correction. So we have to do a correction here. So let me start a new script here, and let me just put, let me just take up to this. So what I will do here, let me just, so I was up to location, right? Let me just take up to location. Let me just clean the entire thing. Up to, I'll just take this up to this. Okay. And then here is the location. Up to total square feet, and then here is the location, correct? So then what I will do, I will just go and fix, I will just take this random stratified sampling strategy, but I'll do in a slightly different way. So I'll tell you this, how we will do that. Let me just copy this part. Okay, let me just copy this part, and you will understand what I am doing here. So first thing I'm going to do is, what this piece of code is doing, it is taking, so let me, it is, I hope this is location names, yeah. So it is for the ith location, it is just creating a subset, sub data set, df sub, and then it is seeing what is the number of samples in that df sub. Now here I'm going to do something interesting. If n1 is less than 20, if n1 is less than 20, that means I have total number of instances for a location is less than 20. I am going to put all the locations for that, all the instances for that location into the training data set. Okay, so df train equal to rbind dot data dot frame df train comma df sub. All the instances goes to the training data set. I will not have enough data to even test that location. If going forward more, but at least my model will be trained, and if in future if somebody wants to come up with a test location, test additional points, we can do the test, or at least model will have the capacity to give you for a test point what will be the predicted value. It will be able to give you that. Else if, now here is an interesting thing, if what happens is n1 is less than equal to 20 and n1 is less than 30, so between, if it is, the value is between 20 and 30, if it is value between 20 and 30, then what you do is you randomly draw 20 samples. So minimum 20 sample you need, boss. So sort sample 1 each to n1. So if there is a 28 instances, you randomly draw 20 of them, place equal to false, and put them in train, df train to df train, and IDX. So those 20 samples will go into the training, and rest of the samples will go to the, if there are 28 instances, so 8 sample will go to the DF test. So DF test minus IDX. Okay, and else it will just behave like a normal, like 70% will go to the DF test. And yeah, so here I already have written, so 70% will go to the train and rest of the samples will go to the test. So this is what I'm suggesting here. So let me just run it through. Okay, and then I'm going to drop the first few rows. Now I'm going to call the first model. I'm going to run the first model that we have had. Okay, so let us run the first model, copy the first model, and that gives us 39% accuracy. Okay, that's fine, we will live with it. And if you add model 2, so that gives us 59% accuracy. Okay, and finally if we just do model 3 and summary 3, now we are getting almost 82% accuracy. So we are reaching to the prior level if we have a correctly done modeling. Now I'm going to do the prediction. So DF test equal to, $price hat 1 from the first model, mod 1, new data equal to DF test. Okay, so if I have the, so this is the first prediction. Okay, so this is the first prediction, and then we will have the second prediction from the second model. I think there must be some issue. Let me check the code. If I'm not sure if I have done it correctly, something wrong must be. Okay, DF train is different from sub. Oh, okay. So here is a mistake. I can see Control C, DF test, and it should be DF sub. Okay, so this is the mistake that I made, and then DF does sub. Yeah, rest of the thing is fine. So let me just run it once more. I hope. Let me just run it once more. So these are the typical mistake I often make, but I hope mistake is divine. Some people say mistake is divine. Okay, 39%, and let us see the model 2. Okay, 59%, and let us run the model 3. 82%. So now it is fine. Now you see there is no issue, so we can run this DF test. Yeah, 62, 61, 131, 58, 50. All right, and finally we just plot 3 hat 3 exp and model 3. If we just run over that, I'm sure test will have the third values, which looks like reasonably okay. All right, so we have some test values, and now what I'm going to do is I'm going to calculate the root mean square error. RMSE out 1 is equal to, all right, so df test price 1 minus df test dollar price square, take the mean. You have to take na.rm equals to true, because there could be some cases where you may get NAs if the all values are not available. You see out 2 will be based on price at 2, and see out 3 will be based on price at 3. Okay, so all right, so if I just say RMSE out equal to out 1, 2 equal to out 2, and 3 equal to 3, C so out so let us run this guy, and now so this is the root mean square error 77, 71 and 59. So this is RMSE out sample RMSE. Okay, so let us, okay, we will do that. Next is we compute out of the sample R square, out of the sample R square. I think what we can do, we can just take these questions, take these things probably, yeah, out of the sample, and then if we just compute this RC, and I think R square 1 2 3, these are out of the sample R square, and 3 equal to 3. R square. So out of the sample R square for the third model is near 75%, where the in sample was near 82%. So there is not much overfitting is happening, which is very good actually, very decently. Looks like there is not much overfitting happening. Now we can choose some new models here with all the all the engineered feature. Let us run that. And if you run this, so these are the all effectively total square feet, square, cube, and bathroom, BHK. They all have a quadratic and cubic kind of effect. So we can just compute both these values, those out of the sample RMSE and R square for both model 4, and then we just compute this too. So if I just run this out, so this is my okay, so this is, I think we had a RMSE out. I think here I have a RMSE out equal to RMSE out comma this. Just a minute. I think I have this RMSE out equal to RMSE out. So I can have this. So 59.98 and 59.01. So looks like third model is better than the fourth model. And let me out of the sample R square, let us look into this. Yeah, third model looks like better than the fourth model. So looks like third model is better. So now we can have try the tree regression also. So we can try tree regression as well. Here I am not using again random forest because it will take a lot of time. We can try that, but I was trying that, it was taking long time, so I'm refraining myself doing that. Okay, so it's not like I can't do that, it just you have to wait long time. For some reason my system, it was taking just too much time, so I'm not trying that in this case. Okay, so RMSE out 74 and out of the sample R square is 56. If I just them, so okay, so tree regression is giving us 75%. It's not as good as the model 3 or model 4 after log, even after log transformation. We have taken log price, log total square feet and all those things. So even there it is not giving, decision tree is not giving, tree regression is not giving that well. So you have to be very careful. So all right, and some residual analysis for the best model. So we have to do some residual analysis, that if we run the residual analysis now, so residual analysis is from the third model. We got from the best model, we got the third model. So effectively if we just do 20, let us see, yeah, or maybe 50, might be it will be better. Yeah, so it looks like x lim equal to minus 222. So it's main equal to this, and if I just zoom it, you can see that it is somewhat behaves like a normal or bell shaped, But if we just do the QQ norm, we can see that it's not really, it has both sides is quite heavy tail distribution. In the middle it is doing fine. That means there are quite a few cases where you are having very high underestimation or overestimation. And I was also trying to do the, let me just all those BP test, Bush-Pagan test. I did those Bush-Pagan tests to, and turns out Bush-Pagan test was also not very good. Yeah, and if I just do few more analysis, for say Rajajinagar, okay. So one thing I was thinking of that instead of in the color, instead of giving black, what we can do, we can just say df sub dollar whatever the bhk that we had. So if we just run this in this way, so these are the plots that we have. So on the x-axis, x level, we have the total square feet, and on the y-axis, y label will be price. So if we just run it, so this is total square feet versus price, and then we have the price hat. And if we just put a points, and now if we just say, you see this certain prices, different prices, you just have a different value. Now, so this is an interesting phenomena that we are seeing. And then I think what we have is, what we are trying, we can try to plot in log scale as well. So probably that will be a bit easier. So if we just put log scale, and we can just say log of total square feet and log of price, and then total square feet and price hat. So let me just zoom it. So there are some red cases. Red are the 2 BHK, green I think 3 BHK, and blue are the 4 BHK. And then, so as people left from 2, 3, 4, then it's kind of went on different level. So price for same number of the exact square feet, if you have more BHK, I think your price premium will go up. You have to pay a premium of the price for the number of BHK because functionality of the home goes up. So with this, I will stop here. I think now most of the issues of this data analysis is fixed. I'm going to share this data, this code, correct code, on the Swarm portal of the NPTEL. And in the next video, we will begin with a new data analysis with a new real life data. Thank you very much. See you in the next video.